excited to be here. Last year I was here and I had too many slides last year, and I have too many slides this year as well, so I need to hurry up. I'm not going to talk that much about myself. I want us all to get into the Tensorflow. So 4 weeks ago, when I was like really realizing that I would be gonna go here and talk about Tensorflow, I was like, Tensorflow, I wanted to learn it. That was why I, applied to have this talk. So I was like, Tensorflow, how hard can it be? And I started to look at the, how Tensorflow works. Then I realized, oh, it's like this machine learning thing. It's like really, really, really complex. And like people studied this for 5 years. And I was this huge douchebag and thought that I would be able to like learn all of this in 4 weeks. I freaked out. And I was like, maybe we're going to do applied machine learning instead. So that is more like, maybe you don't know the internals, the mathematics of it, but you can still apply the machine learning on like problems that you have. So I was like, fine. But then I was like, this is also pretty hard, and I was freaking out. So this was me 4 weeks ago. So when I have this feeling, what I like to do is to go back in time and then try to create a mental model going forward so I understand the problem. So this is going to be a little bit weird, but please follow me on a journey back in time. So this is the Earth, that's the Sun, and that's the Moon and some random planets, which probably not are accurate. These are computers and programs, and if you don't see it, it's kind of a joke with the space cat and the owner holding it. I thought it was fun. But the cool thing with programs and computer is that you can take rules and laws, complexity, and put it into a computer, and out you get a program. So that's super cool. So that's nice. But then we get the smartphones, and the smartphones are really interesting because they have microphones, they have speakers, they have cameras. And when you think about it, there's something else that has kind of similar inputs and outputs. That is humans. We have ears, we have mouth, and we have eyes. So when you think about it, it's really weird, comparing these two, but you can kind of say that we're very similar in that sense. So if you think about it like that, then as a human, you can start thinking about problems that we have on a daily life, and it's not weird to start thinking that, oh, it would be really cool if I can start solving problems like I solve problems as a human. So here's a really weird example. If I have a camera and I take a photo of a cat, I want to pet it, but if I take a photo of a snake, I want to run. So it's like pet or run. A really weird app, obviously, but it's not weird to think that you want to create this. So you sit down and you start writing or collaborating with this program, and the program is like, you realize eventually that the complexity of specifying how a cat looked like and how a snake looked like and do if and else statements, it's like impossible. You cannot do it yourself as a human. So what can we put in here that takes the world as its input and then outputs a program? 10 years ago, we would have been like a little bit sad and we would say like, we cannot do that much if we're web developers or app developers. But now, we have the machine learning robot that can help us out. Look how friendly and nice this robot is. So you take the world as an input to this machine learning robot, and then you give it some training, you tell the robot what it's looking at, and then eventually you get out like a model or a brain. And then you can take this cool brain, and you take the world as the input, and you run that through the brain, and then all of a sudden you can get predictions. Super cool. So just to get you all excited, I want to show you a weird little demo. So this is what I call the what hand bot. So let's turn the what hand bot on, and we are now live. So I'm going to press this left button here, and I'm going to start scrolling around. So what I'm doing now, I'm telling this bot that I'm a left-handed person, and I'm using this homepage right now, and I'm touching it on the left side. And we can see that we're giving it a bunch of examples, and we're scrolling down on this awesome homepage with cool articles. And the best, this is the best. I try to be like meme-free, but this cat meme is, like if we're going to send like a new kind of golden disk into space, I think it's going to be of this cat. And then we're going to teach this model a little bit on the right side as well, so give it a lot of input, touch events. So what we're giving this bot is like our touch events when we scroll around on the page. But obviously, if we would be on the phone, it would be like the touch events. So we're doing that. So let's go up to 10 examples. Boom, 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 boom. There we have 10 examples. Cool. So now we're going to tell the robot to kind of consume all of this information, and it's thinking, and it's really quick, and it also reached 100% accuracy, which is Cool. So now we're going to ask this robot to start listening to our input and tell us what it thinks we're doing. Oh, you see? So now on the right side, it says right. It moved to the right. That's pretty cool, but there's a little cool thing too. If we go to the left side, we scroll, it moved to the left side. But also, if you look at the hamburger menu, it moves to the left and to the right. So what I wanted to show you here is that what if we started doing this with like home pages? Like if a user is left-handed, wouldn't it be pretty cool if we move the UI around so people can actually reach it? Because the phones today are like enormous. Steve Jobs had a reason for wanting the phone to be like the iPhone 4 because we could use it with one hand. So I just wanted to show you this weird demo that you can like maybe, move the hamburger menu around and you can click on it and have it pop up. But anyway, let's close that one and continue. So this bot thinks it's pretty cool. It's bragging here right now. So let's get into the internals of this bot. So the internals of it is Tensorflow. And Tensorflow is super cool because you can run it in the browser and you can run it in Node.js. So in the browser, they use WebGL. It's super cool. They run all the machine learning stuff in shaders. You have to be really smart, I guess, to solve this, but some smart people manage to do that. But if you have a sad phone that doesn't maybe have the WebGL support or whatever, you can use your CPU. And then on the Node side, you can actually use like discrete GPU to train your models and stuff. Sadly, it only works with NVIDIA cards, and that kind of sucks if you have a Mac because Apple doesn't support NVIDIA cards. So if you're like myself who bought like an eGPU and an NVIDIA card to be able to do machine learning stuff with your Mac, you are a little bit upset, but it's fine. But you can still use the CPU. So Novice, they told me that I'm an expert at machine learning. That's not really true. I'm like 1 month in. But a person like me, when I started looking at it, this is how I split up like the internals of it. If I would have had 6 more months of this, this might look a little bit different, just so you know. But we have tensors, we kind of have operations, and then we have the cool part, which is like the models and the layers. So let's be really quick here. So tensors are kind of like the core data structure in TensorFlow. So it's used to turn data into something that our models and brains and stuff can work with. And here's like one example in the top left, bottom left corner, how you can create a tensor. So you take the values, and then you take a shape, and the shape can be like 6 dimensions, like it's super complex, it's confusing. And then you can specify the data type. And the robot obviously thinks that these things are very yummy. And then you have operations, and operations are mainly done on tensors and are immutable. So if you have a tensor and you do some kind of operation on it, you get back a new tensor with an operation applied to it. And it kind of is used to manipulate and change the data around and combine. And in this little box, you see like basic, matrices, convolution, blah, 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 blah. So these are just the headings of a subcategory of operations you can do. So there's like hundreds of operations. So when you look at the API for the first time, it's like, it's overwhelming. But to be honest too, there's so many cool examples out there, so you can kind of start from the example side and then go into the API and like try to figure it out. That's how I did it, and it was really fun. But then, we have the models and the layers, and that's the cool part because that's how we, create these awesome brains. And why I say it's brains, because if we talk about like neural networks, which I'm going to focus on today, they are kind of model like how our brain works. And I think that's, if you think about it like that, it's way more easy to think about problems and how you can find solutions for them, because we know how our own brain works or what kind of problems we can solve ourselves. So a model is the brain of the machine learning robot, as I said, and it can learn by accumulating information and knowledge. And then you train the model, just like a parent, give a child information, and then this child sits down and think about the information, and eventually it can make own assumptions and predictions about the outside world. So let's zoom in on this brain as well, and this is where I get a little bit nervous, but so what we're looking at now, so we zoomed into a model, and inside of the model we have layers. So you always have an input layer and you always have an output layer. And between these two, you have hidden layers. And they can be many, many, many layers. And you can think about the input layer as like your eyes. So you have the input into your eyes. And then the hidden layers is all the parts in your brain. And then the output layer is like your consciousness that can, like if I look at a cat and I just know that it's a cat. That's like the output layer. So you want to specify the output layer so it's something we as humans can understand. And yeah, and all these little parts in this neural network is neurons. And a neuron has inputs, and an input has a weight attached to it. The neuron itself has a bias attached to it, and that's kind of fixed, whereas the weight is multiplied with the input. So this is kind of a really simplified function, but you take the input, multiply it with the weight, that's the name, weight, and then you do that for all the inputs, and then at the end you add the bias. And this then is kind of run through what's called an activation function. And the activation function is basically like, should the neuron in our brain, activate or not, send the impulse based on the value it's getting in. So there's two functions that people usually use. It's sigmoid, which is what people used the most back in the days, but now people are using ReLU way more because apparently it simulates how our own brain kind of works when it's figuring out if it should, activate or not. So the final thing I want to say here is that when we train our model and trying to find a solution so that the model can kind of, get smart and predict stuff, it's the bias and the weights that we tweak. And the mathematics behind this, how to do it, I will not try to explain it because it's super complex. Maybe next year I can be here and be an actual machine learning kind of expert and I can deep dive here. But for now, I'm going to just leave that and tell you all that all of this is really complex, but it's really pretty cool too because there are a bunch of these brains or models out there that we can use. We don't have to know all the internals of it. We can use pre-trained models that TensorFlow offer for us. And the robot is obviously like a bunch of brains. That sounds weird. So let's have another demo. So this is the music bot. And you probably saw that I brought up a ukulele. So let's turn on the music bot. I hope you will be able to hear it. I'm going to hold it close to my microphone. That was chord number 1. Chord number 2. And then chord number 3. And then we're going to add the noise, like how is this room sounding like, so you can figure that out as well. And I can actually talk now as well, because that will just tell that my voice is noise. Maybe you think that too. That would be sad, but who knows? OK, so now we're going to let it think. This is going to take some while, so I'm just going to play some background music here, like waiting music. OK. So I guess you all know what's going to happen now because you've seen this awesome kind of bot before, but we're going to tell it to listen again. What's going to happen? OK. It's pretty cool, right? So it's funny because this brain, this pre-trained brain that we use here to do this kind of weird chord thing, it was actually a speech command recognition. But I was like, yeah, sure, it's trained to recognize like left, right, up, down. But we can just repurpose it and train it to understand chords. And it worked because what I wanted to convey to you all is that that's kind of how our own brain works too. Like if I can, hear that you're saying left or right, I can probably also separate, chords from each other. So I think it's really important that we start thinking about like, what can we self-do as humans, and then start applying that to the web stuff we're doing, because we have the tools there now. But here is a bunch of different kind of models, pre-trained models we can use, like image classification, object detection, speech command recognition, KNN classifier, which I'm going to talk about like now, body segmentation, pose estimation, like how is the body moving around, and then toxicity, which is pretty cool. Like you can take its string of a message, and you can get back, is this user douchey or not? And so that's good, and we can block them or whatever. So yeah, quick demo time again. So this is the part of my presentation that can kind of, there's a lot of things that can implode here, which is okay. So I'm going to put this here. I'm going to press the button here to make sure that it's using the USB cable. And I'm going to scroll, and I'm going to see here, we see 2 cameras, so that's good. We're going to turn on the robot, and hopefully we can, oh yeah, baby. I was so nervous. Okay, so let's pretend now we're Apple. And Apple, we're not even going to have to pretend. This is the truth. When you open the support app at Apple, and you open it, and let's say we have a problem with our computer. It's not charging. So we open it, and, power problems. And you immediately get to call support. And imagine working at the support and having to tell all these people, like, hey, you should probably have you charged your computer? Does your computer have power? And then they look at their computer, oh, I forgot to turn on the charger. It was not plugged into the wall. And it's like, okay. So what if there was a way that you can use an app, and then you could, before people call in, you can tell them to record the computer a little bit, and then we can tell you what's wrong with it, maybe. So that's what we're going to do here. So we're going to use this camera, and we're going to start telling this machine learning robot that we're charging right now. So a bunch of examples saying that we're charging. And you see there's a lot of tape here. It's because last year I accidentally plugged out a cable that ruined the whole demo, so it's not going to happen this year. So we take that out, and we move it away. And now we're saying not charging. So there we have it. The app is ready to go. Tim Cook is ready to give me $100 million because it says not charging. Thank you. That's awesome. But then we do this. We put it in again. A little bit. You can see how it's not full in. Now I'm going to get sued by Apple instead. But the cool thing is here that we can just give more examples. Whoop, 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 whoop. So we're giving in, it's not charging. So now it says not charging. When I plug it in again, it's probably going to say that it's not charging. So we have to give more examples that it's charging now. So you can kind of figure out the difference between not charging and charging. And we take it out a little bit again. There we go. Okay, not charging. Maybe I have my camera too far away, so the resolution doesn't pick it up. That will be okay. You can just trust me that it should work. Okay, we do it one more time, just to make sure. Let's see here. Plug it out a little bit longer, maybe, than we did. Oh, there we go. So we can now pick up even that small little detail. So this is pretty cool. We train this now. And obviously, if you would have done this, you would have thousands of pictures to do this kind of training so that it would be more accurate. But now I'll take out another cable. This is a USB cable, but we're going to pretend that this is a charging cable. We plug it in, and it says that it's not charging. That's bad. What I've introduced into my model is something called a bias. My charging cables that have another color does not, say that it's charging. And this is something that is actually really important if you're going to work with this, to think about that. You need to think about the diversity of your data that you're putting in, because you don't want people to feel excluded. If I would use an app and it doesn't recognize my face, that's so bad. So really important to think about. But yeah, I think that's it for this demo. I'm going to remove all these cables, and we do that. We can actually, we can take out this too, so it's not in the way. Okay, cool. So what we were using here was something called a KNN classifier. And what's so cool with that is that it kind of scans brains. So what that means is that we take a brain, which is a model, and in this occasion we use MobileNet, which is a brain that is really smart at taking an image and then finding certain uniqueness in it, if that makes sense. But what the KNN classifier do is it scans the state of the brain. Then you get out like an input that you can then use as and classify. So here's an example. Hey, our brain just saw a cat. So the classifier scans the brain and then take the state of the brain and saves that. So it knows in the future that, yeah. So another example, if we send in a dog, we scan the brain, we get out the brain state when it looks at this photo, and we have that. So then eventually what you can start doing is you can ask the scanner to scan the brain when you don't know what it's looking at, and it can look at its knowledge and then tell you that, oh, it's a cat. So what this means is that you can take a really smart model and you can repurpose it to do other things as long as it's good at what it's supposed to be good at, and in this occasion is to take photos and find things that are unique in it. So, we're at the JavaScript conference. I guess I should show some code. So let's do that. So this is pseudocode, I think you call it. But it's very similar to how it actually is. I just removed a bunch of UI things and imported this dummy thing instead. So what we first do is that we import Tensorflow. Then we import our fancy brain, which in this occasion was a mobile net. And then we import this super cool scanner, the KNN classifier. We initiate our robot, and it doesn't have a brain right now. It doesn't have the classifier, but it do have eyes. And we tell the robot to wake up, or once we call that function. And we load the fancy brain, and then we create our classifier. And then we tell our robot to start working. But if you look at the work function, it kind of works by looking if our classifier has any knowledge. Get num classes. That basically means like, have we specified have we learned our classifier anything? And if that's greater than 0, then let's do something. But since we haven't, it's better that I explain the explain function first. So what that is that you tell the robot that. So in our occasion, it was when we clicked charging or not charging. So when we click charging, you get to this function, and the explanation is that it's charging. So then it takes the state of the brain, and it kind of say that, okay, we classify it as charging. And then eventually, when we have more classes, the work function will be able to know what it's looking at, because we do run this over and over again, and we ask the state of the brain, and then we ask the classifier to predict what it thinks it's looking at. And then we're basically just updating the UI to make sure that all this, it looks fancy and stuff. And then we run a dispose thing, and what that is basically clearing up the memory so that our memory doesn't implode. So I think that's it for now. I'm going to tell you all that all the code that I've been writing for all these examples, I'm going to make them available, hopefully today, so you can deep dive and try it out yourself. So don't be worried about that. So there's one more thing, though. We said web browsers. We said Node.js. What if I told you that like 1.5 months ago, there's a new member in this club? Because maybe some of you were like, oh, this sucks, I work with this other thing, and it's so fancy for all the web developers that can work with this. You can actually do this in React Native now, which I think is pretty cool. So it just works the same way as it does in the browser. Sure, there's some setup. It's actually it takes some time to set it up, but once you got to state where everything works, you can just use this as you would have used Tensorflow in the browser. So it's really cool. So I actually have quite a lot of time. That's pretty cool, because then this final part, we can spend some time on it. So I want us all, before we close it up, to be a little bit wacky. So I want you all, if you want to, you don't have to, go to this URL. You need to allow home pages to access your camera. If you think that's sketchy, that's fine. It's okay, you don't have to go here. But what I basically do, I use the camera to do something, and then I run everything locally on the phone, and then I send just a tiny information to a server that I have. But it's nothing about you as a person, it's nothing scary, it's just like basically maybe a emoji that I'm sending over the line. And I'm gonna open this, and if people start going in here now, we might start seeing emojis showing up, and this is actually live. This is people looking into their phones right now, and you know, their facial expressions, which I think is pretty fun. We can maybe zoom in a little bit, so we. If someone thinks this is a cool idea, I'm open for, you know, discussing maybe funding. Emoji Wall has, as you can see, a huge increase in users right now. The curve is pretty steep. You can also look, all of our users are pretty happy, it looks like. Yeah, I was worried that this would implode. I'm just going to say what I'm using in the backend stuff is Firebase. I love Firebase. I'm not working for Google or anything, but it's just cool how it kind of scales. Yeah, wait a little bit more. I just think it's funny. Maybe I have 2 minutes. What do you think about Nordic.js? Is it good? I don't understand voice. I need facial expressions. I need happy smiles. Yeah, they're kind of happy. OK. Did you enjoy this talk? I was going to be like, oh, yeah, of course, some are sad, joking with me. It's douchey. But I feel like we can look at this for very long, but I feel like I should probably wrap it up. But this emoji wall will be open, so anyone can go there. It's emojivall/wall.html. You can go in there if you want to do it yourself. I think that's it. Thank you so much.